This is Physics 1 course. In this video I will solve another example on constant acceleration motion. Two balls are thrown in opposite directions but with the same initial velocity in a direction orthogonal to the Earth. Which of the two have higher velocity when they hit the ground? We first draw a coordinate system. Let's say this is the surface of the ground, and this is, let's say this time we call it Z. It doesn't matter how we form our coordinate system, how we choose the directions. So let's say the two balls are originally here. One is thrown upward, one is thrown downward, and they both have initial velocity v0, but with different directions. So one is positive, one is negative. The only acceleration in this problem is gravity. As always, it is downward toward the surface of the Earth. We show it with G. For both of the problems, we need to solve or use two sets of equations. One is Z equals Z0 plus VZ0t plus half AZ, which is minus G, t square. And also V equals VZ equals VZ0, which is either that for the other one particle or that for the other particle, VZ0 plus AZT. Let's focus on this other particle. It goes all the way up and then goes all the way back down to arrive at the same point, and then continues to move toward the surface. So, but we know that when it goes back down here, the Z is equal to Z0 because this distance is already Z0. So let's say when Z of the top particle is equal to Z0 equal to now I'm writing this equation, Z0 plus VZ0 t plus AZ is negative G because G is downward, so therefore it's negative half G t square. So if I cancel this and this, then I have this equation. I factor t VZ0 minus half GT. So as you can see, this equation has two answers or two solutions for time. So either time is equal to 0, then this equation is satisfied, or t is equal to 2 VZ0 divided by G. So this is when the particle started moving up. The other solution is when the particle went all the way up and then goes back down. Now if I calculate VZ at this other time, then VZ equals VZ0 is plus V0, AZ is negative G again, and T is 2 VZ0, which is V0, divided by G. Now if I cancel G and G, then VZ will be equal to V0 minus 2V0. So it's minus V0. That means when the particle is back here, the velocity is minus V0. So the particle has minus V0 velocity. So since these two particles at this position have the same initial velocity and also initial height. Therefore, the speed at which they arrive at the surface of the ground is exactly the same. Therefore, answer to this is both have the same velocity, so none have higher velocity. Thanks for watching. Please subscribe to support my channel. If you have any question or comment, please send me an email at open.physics.project@gmail.com. Thank you.